All right, now that we're in section 2.2.1, multiplying expressions, and we went over our little example with Jonah and Graham, a couple of things to just keep in mind that when we multiply expressions, we have two ways. We have FOIL and we have what we call the area model. FOIL is, in my opinion, easiest to do when you're multiplying a binomial times a binomial. Remember, binomial means two, so when you're multiplying something that has two terms times two terms, FOIL, in my opinion, is the easiest. Where if you have area models, I think an area model is going to be easiest or best when you're multiplying trinomials. And again, it is personal preference. You can use either method for either way. So if we look at our example here, I have a binomial times a binomial. So as I FOIL, I have 3m minus 1 times 8m plus 7. And again, FOIL stands for first, outside, inside, last, or double distribute. So I take the first terms, 3m times 8m is 24m squared. 3m times 7 is plus 21m. Negative 1 times 8m is negative 8m. And then negative 1 times 7 is negative 7. And again, you're always going to have like terms that you then want to add. So 24m squared plus 13m minus 7. If I was to do that with an area model, what you do is you make a rectangle or a square in this case, and you write your factors on either side. So I'm going to have 3m minus 1 along the top and 8m plus 7 along the side. And since there's two terms, I'm making two columns. Since there's two terms on the up and down, I'm going to make two rows. And this reason called an area model is because you're finding the area of each rectangle. And remember, to find the area, you multiply the base times the height. So this is 8m times 3m, or 24m squared. This is 8m high, negative 1 wide, so negative 8m. 7 times 3m is 21m. 7 times negative 1 is negative 7. And you will always have like terms along diagonal, which we then have to combine. So there's no other m squared, so it's 24m squared. I have the diagonal like term there, which again would give me 13m, and then minus 7 at the end. So again, same answer, just different ways. But again, I prefer, if I have a binomial times a binomial, I prefer FOIL. I think it's going to be faster. As we go to problem down here, now I have a trinomial times a binomial. So if I were to FOIL, it's not necessarily FOIL anymore, but what I'd have to do is I'd have to take 3x squared times both my terms here. So I'd have to take 3x squared times 3x is 9x to the third. 3x squared times negative 8 is negative 24x squared. Then I have to take negative 5x times both the terms. So negative 5 times 3x is negative 15x squared. Negative 5 times negative 8 is positive 40x. And then I have to take the 9 times both the terms. 9 times 3x is 27x, and 9 times negative 8 is negative 72. And then I have to combine like terms. So I have 9x to the third, x squared's right here, which would be minus 39x squared. I have my x's come next, plus 67x, and then minus 72. And it doesn't always work out that way where your like terms are right next to each other. That's just so happened to be the case. But again, this was kind of a little messy. You're multiplying a lot of different exponents, so it's kind of easy to make a mistake. This is where I would like the area model. So for the area model, now I have three terms, a trinomial. So I'm going to make three terms along the top of my rectangle. So 3x squared minus 5x plus 9. So when I go and make my rectangle is going to have three columns. Then I still am multiplying that by two terms, 3x minus 8. So I'd have two rows. If I was multiplying this, if this was a trinomial, then guess what? I would just have three rows. So now I'm finding the area. So 9x to the third. 3x times negative 5x, negative 15x squared. 3x times 9, 27x. 3x squared times negative 8, negative 24x squared. 8 times negative 5x, positive 40x. And negative 8 times 9 is negative 72. The reason I like this is because I see diagonals as like terms. My like terms are always diagonals, which is going to be a good thing because it's easy to catch mistakes that way. So when I add my like terms, I have 9x to the third minus 39x squared plus 67x minus 72. So again, you get the same answer either way. I don't care which way you do it. I just prefer the area model because it's a little bit more organized. I know I multiplied every term by what I needed to because all the area blocks are filled in, and I can also double check myself because my diagonals should be like terms, and if I find out like that this wasn't an x squared for some reason, I would want to go back and check my work. So it's kind of a little bit of self-checking at the same time. So it's up to you what you want to use. A couple other quick things. Number 2, just be careful. Again, like our problem up here with Jonah and Graham, when you have a binomial squared, remember to write it twice. And then once you write it twice, remember to FOIL from there. So again, this would be x squared minus 5x plus 25. And when you add your like terms, x squared minus 10x plus 25. Just always remember, binomial times a binomial, write it twice. Other than that, if we take a look at one other kind of key aspect here, if we look at number 5, when I have a number in front here that I multiply by 2 binomials, I'm going to think about what you would do here. If I had 2 times 3 times 5 and multiply 2 times 3 first, get an answer, and then multiply that by 5, right? I wouldn't take 2 times 3 and 2 times 5 at the same time. Same thing here. I'm going to take 2 times the first factor, or the second factor. 2 is my first factor, and multiply that by my second factor. So I'm just distributing that first. 2x minus 10. Now I take that answer, still multiply that by the third factor, x plus 5. So now I have to FOIL. So 2x squared plus 10x minus 10x minus 50. And so I'd end up with 2x squared minus 50 as my final answer for this one. And just remember, as you go to something like down here, a trinomial times a trinomial, I definitely would use an area model in my opinion. And then you would just have 3 rows and 3 columns. Again, it's up to you how you want to do it, but just be careful for these. You do have pluses in between as well. All right.